Now for our bi-weekly look at science with our favorite science educators from the Discovery Centre in Halifax. And this morning we're blowing things up under the expert supervision of Jesse Bridle. Good morning.
Good morning.
Expert supervision, that's good, because I wouldn't want to be on my own on this.
That's right. This is definitely a do not try this at home situation.
Do not do this at home. Leave this up to the educators at the Science Centre. So what are we going to be doing?
Well, we're going to look at some hydrogen
today.
So everyone's been talking about the Titanic. It's the 100th anniversary of the Titanic disaster, but there's another important disaster anniversary coming up. On May 6th, it will be the 75th anniversary of the Hindenburg. Which you might have heard was a Zeppelin, which looks kind of like the Zeppelin that I've got
here. So this
here.
is sort of a model.
That's right. So a demonstration of the shape, the size, about what it would have looked like.
Yeah, so it's basically an airship.
An airship, exactly. Yeah. And they were very popular in the 30s. This one is full of helium. So just like a party balloon, it can float because the helium is lighter than air.
Right.
Now, helium is not quite light enough for airships. When you put people and machinery and that kind of thing, it's pretty heavy. And helium's hard to get in large quantities. But hydrogen is pretty easy to get. And hydrogen is about 4 times lighter than helium. So it's got a lot more lift.
Wow. Okay.
So they used hydrogen in the airships like the Hindenburg. But hydrogen, unlike helium, is flammable.
Oh, yes. Hence.
And in the right situation, it can be explosive.
Right.
Now, I've made some hydrogen.
Happened, unfortunately.
That's right. It's what happened. It was a terrible disaster. That's the Oh, the Humanity, the famous video.
And it was kind of the end of airships as well.
Pretty much, yeah. And it's probably good that they're no longer with us. They were really cool, but quite dangerous. And we'll see exactly why.
Helium not flammable.
Not flammable at all. Helium really likes to stay helium. Hydrogen likes to become other things. I'm anthropomorphizing a little bit, but it's a fine way to think about it.
Right, kind of on a molecular level.
Exactly. It's very easy. It likes to combine with oxygen and become water. So H2O means hydrogen and oxygen come together and make pure water. Which is what we're going to see. But we're going to see that happen very quickly with a lot of energy.
Oh, okay.
So I would like you to help me. I want you to put on those safety glasses just in case.
It's always good to do.
And you're going to light this candle here.
We're going to light the candle. There we go.
All right, so I want you to hold that stick out.
Okay.
And if we could get the lights down just a little bit,
so
maybe we can see this fireball a bit.
Has hydrogen in it.
This balloon is mostly hydrogen.
Okay.
And when we hold the flame up to it, it'll take a couple of seconds to melt through the balloon.
Oh, really? Okay.
Whoa!
Woo!
Yeah, pretty cool, huh?
Yeah, oh my God. Do it again,
Do we want to do it again? Okay, if we've got time to do it again, I can do another one. We've got a bit of a smaller balloon this time. Do we have the tape in there as well?
Where's the tape?
Great.
Oh my goodness. Okay,
it's pretty exciting, huh?
So on a scientific level, what happened there?
So there was hydrogen, which is 2 hydrogen atoms make a hydrogen molecule. So it's H2 in the gas by itself.
Okay, in the gas alone.
Let's see, we'll do it on this side. So it's H2, which combines 2 hydrogen molecules combined with 1 oxygen molecule. Now, an oxygen molecule is O2.
Right.
And that makes 2 molecules of water. So 2 H2O.
Right. Oh, okay.
The math is fairly simple.
Yeah.
And with that, there's a big release of energy, which comes out as some heat, although it's not a super hot explosion.
Yeah.
Lots of light. And that big sound.
And that big sound. But should we have produced water at some point?
Well, yes, but just a little bit. Because what we've got is gas in here, and the water becomes a liquid right away, and the liquid takes up very little space compared to the gas. So there's a little bit of water vapor that's mixed in with the air, and it just disperses very quickly.
And it just dissipates.
That's right. So we're not going to get a splash.
Let's do that again.
All right.
All righty. Oh, boy. Here we go. Wow, that is way too much fun. But remember, do not do this yourself.
Absolutely.
You need a professional from the Discovery Centre. Pop by the Discovery Centre on Barrington Street in Halifax. They always know how to have a lot of fun and explain science at the same time. Jesse, thank you very much.
You're very welcome.